Hi, Year 5. We wanted to put a little bit of extra work onto our equivalent fractions this week because we know that we are recognising them really well with diagrams, but we need a little bit more practice when some of those diagrams disappear, and really making sure we fully understand those relationships between two fractions which are equivalent to one another. So here is a little bit more practice for you today. First of all, then, we'll warm up with some questions that look a little bit like this. We've got some bar models, and each bar is representing a whole, okay? And I want you to look carefully at these images here and think, well, if this is the whole, this one here with the yellow bar and the white bar, how many pieces are there in my whole? And how many pieces are coloured in? Well, I'm looking at this one and going, the whole is split into two equal pieces, and I have one of them coloured in. So that's 1 out of 2 pieces, or 1/2. The second bar here, I have 8 individual pieces. So I have 8, the whole has been divided into 8 equal pieces, and I have 4 of them coloured in. So I know that 4/8 is equivalent to 1/2. Wonder if you can have a go and look at the other ones now. Have a little look at them and see how you feel. How did you get on? Could you work out the fractions? Well, this one, first of all, let's show the answer to the one we just did together. So we have 1/2 is equal to 4/8. The next one then, I've got 3 equal pieces in my whole. I have 1 of them. And here I have 12 equal pieces in my whole, and I have 4 of them. So that tells me that 1/3 is the same as 4/12, or is equivalent to, has the same value as. Let's have a look at this one. I've got 5 equal pieces in my whole, and I have 3 of them. And here I've got 10 equal pieces in my whole, and I have 6 of them. So that tells me that 3/5 is the same as, is equal to 6/10. And finally here, I had 1 piece coloured in. There were 4 equal pieces altogether. So that means I've got 1 out of 4 pieces, but we said that's 1/4. And here there were 8 pieces in my whole, and I have 2 of them, therefore 2/8. So 1/4 has the same value as 2/8. I hope you got on well with those. There's a few of those to practice in your work today. You might want to pause the video now and go and have a go at those, or you can carry on and then do all of your work at the end. Okay. Now this is where it becomes just a little bit trickier, and we have to be able to understand the relationship between those numbers, and the diagrams really help with this. And I will show you a way that you can make some diagrams yourself. But let's just have a look at them first of all. And in fact, I might just go back just a tick and just have a look at these here. I want you to look at the relationship between these numbers, this one, and our denominators here. So from my numerator to the other numerator, can you see what has happened here? Well, if I look at the diagram, for every 1 piece in this bar, I have 4 pieces in this bar. You can see here, there's 1 and there's another 4. So I've actually done 1 and I've times it by 4 because there's 4 pieces to that 1. I hope that makes sense. So it's 1 times by 4, and that makes 4. And because my numerator here was 1, and I've times that by 4, my denominator is 2. There were 2 equal pieces, and both of those equal pieces have got 4 pieces in the bar below. So I've got to times that by 4 as well. So I have to multiply the numerator and the denominator by the same amount. So 1 times 4 is 4, but 2 times 4 is 8. I hope that makes sense. Let's just look at this one quickly as well. 1/3, so I had 1, 2, 3 equal pieces, is the same as 4/12 because there are 4 equal pieces underneath each individual third. So I've done 1 times 4 gives me 4, but then I've got to do 3 times 4 to get me to 12. So there is a multiplicative relationship, we call that, between those two sets of numbers. Okay, so let's look at this one then. Can you spot the relationship, that multiplicative relationship, what factor I would times 5 by to get to 15? Well, hopefully you know your 5 times table and you could do 5, 10, 15. You know that that's 5 times 3 is 15. So if 5 times 3 is 15, well, I've multiplied my denominator by 3. So I've also got to multiply my numerator by 3. So 3 times 3 is 9. So 3/5 will be equal to 9/15. Now, I'm just going to open up MathSpot to show you how this could help you as well. Okay, so in MathSpot, we have something called bar modelling, which I think I've shown you a little bit of before. But you can make your bar a little bit bigger. And we were looking there at, I'm just going to double check my fraction quickly. We were looking at, that was it, 3/5. So I want to split this bar into 5 equal parts, okay? And I want to then fill in 3 of them because this represents 3/5. Now underneath that bar then, I'm going to make another bar as well. But that second bar, that needs to be split into 15 pieces because my second fraction, the denominator, is 15. So I can make these parts bigger, make more of these parts. It actually makes the part size themselves smaller, doesn't it? And now I can see my 15ths. So I've got fifths at the top and 15ths underneath. But this one, to make it equivalent then 3/5, I'd have to colour in all the way up to there. And can you see that's 3, 6, 9? Okay, so I've done 3 times by 3, and that's got me 9. But hopefully this would be a useful tool that you might be able to use. I'll pop the link onto our video links page for you so you can access it as well. So just to show you again, all you do is you have the bar. I would definitely make it bigger because it's much easier to see, and then you can move it. And then you split the bar up. So for example, I might have 5 parts to one bar. And then I can make another bar by copying it, and it makes it exactly the same size. And if I click on that bar, then I can change the parts to that one. Let's say this one had 10 parts. And perhaps here then I wanted to see what 4/5 was the same as in tenths. And I could change the colour of this if I wanted to. I can make it look all different. And this time then when I fill in, I'm going to see how many tenths. 2, 4, 6, 8. 8/10 is the same as 4/5. So you can use that if that helps you as well. Okay, so I've come back to this now, and I'm going to look at that relationship again now. So I've got 5, I said times by 3, makes 15. And if you just have a little look, there it is. 5 times by 3 is 15, and then the numerator, 3 times by 3, gives me 9. So I'm looking at the denominators. 5 times 3 is 15. I know I need to multiply the numerator by 3 as well. So hopefully now you might feel a bit more confident. Can you have a little look at this one? What's that relationship? Well, I haven't got 2 numerators. I've only got 2 denominators to be able to have a look at here. This time, my larger denominator comes first, and my smaller denominator is here. So what relationship would these have? Rather than multiplication, I might think about division. You can still think about multiplication as well, though, if you find that a little bit easier, but it is just the inverse. So 12 divided by 2 gives me 6. You can also look at it going the other way and go 6 times by 2 equals 12, if you find that a little bit easier. Now, again, because I've divided this one by 2, I know I'm going to have to do 10 divided by 2. Or think about something times by 2 makes 10. Have you got it? Well, here's that little explanation. So I know 12 divided by 2 is 6. I know I need to divide the numerator by 2. And 10 divided by 2 is 5. One more to have a look at. You might want to pause the video, have a go yourself first before I explain. Okay, I hope maybe you did have a little pause to get yourself feeling a bit more confident. This time, can you see I know the 2 numerators, but I don't know the 2 denominators? I can still work out in the same way though. I can go 4. What can I do to the 4 to get to 8? I can do 4 times by 2, can't I? And then, because I've done 4 times 2 with my numerator, I'm going to have to do something times by 2 with my denominator as well, because I have to change it by the same factor. So 4 times 2 is 8, something times 2 is 12, or I could think 12 divided by 2. Have you worked it out? Hopefully you have. So here again I've shown division, but I could multiply as well. 12 divided by 2 is of course 6. Okay, so that's how you can use that relationship, and it's whatever you do to that numerator, whatever you multiply that numerator by, you have to multiply the denominator by the same. Or you can do it with division if you're going to a smaller number. Finally then, there are some questions here where you've got some missing numbers. And it says here, Mark the Master Wizard is working out some equivalent fractions. And he's written this in his spell book. 2a equals b16. So I wonder if you can find 3 possible pairs of equivalent fractions showing the values of a and b. Have a think for a moment. What could possibly be those values? Did you pause and have a think? I hope you did. Well, I'm thinking here, actually I've got 2 opposite numbers, so I don't know what the relationship is here, which means it could be just about anything. So what if I did 2 multiplied by 5? If I did 2 multiplied by 5, well, that would make this 10. But then I'd have to do a multiplied by 5, and that would be 16. Now that's not so easy, so perhaps it can't be just anything. Can you think of any factors that might help you here? Anything that 2 and 16 might have in common? Maybe you've spotted a couple there. I suddenly thought about 8, because actually I know that 2 times 8 is 16. So what if I did 16 divided by 2 is 8, and 2 times by 2 is 4. That could work. So B could be 4 and A could be 8, because, let me check it again in my head, 2 times it by 2 is 4, and 16 divided by 2 is 8, or 8 times by 2 is 16. That could work. I wonder if you found any ways. I wonder if there's another way. Could I do 16 and divide that by 4? 16 divided by 4 is 4, and 2 times by 4 is 8. That could work as well. Let's have a look at the examples that we've got here. Okay, so there's a couple for you already. This one is quite a clever one, really, because 2 tooths, or 2 halves, I suppose I should say, well, that is a whole, isn't it? And therefore 16 sixteenths, well, that's a whole as well. So of course that could work. Then we've got my other example I just said, 2 quarters is the same as 8 sixteenths. Can you see they're also the same as a half? Because 2 is half of 4 and 8 is half of 16. And the final example they've got here, that was my other one, 2 eighths and 4 sixteenths. They've even found one more. So here they've said 1 16th, because 1 times by 2 is 2. They've done that 16 times 2, and 2 32ths. That's a really hard thing to say. Okay, so what I'd like you to do now is have a think about how you got on with your work yesterday. I'm just going to pause the video and I'm going to open up yesterday's work. Okay, so I'm here in the Google Drive. I'm hoping yesterday you've all had a really good go at doing some of these images here. Maybe had a go at drawing your own rectangles. Then have a go at sorting these fractions. This one you might have found a bit tricky. Perhaps you might like to go and have a look at the bar modelling that I was showing you before, because you could make 1/4 and then you could have a go at making some of these other fractions to see which ones might match with 1/4, and the same with 1/3. Then you've got some pairs of fractions here to find the equivalents of. 7, if I multiply it by 2, I get 14, so 1 multiplied by 2 is 2, so 2 14ths. Make sure you've had a go at those ones for me as well. And then on the second page, you've got some more fractions here. Now, actually, this one, there's so many different ways that you could complete this. There's lots and lots of different possible answers. So then I'd really like you to make sure that you're having a really good go at challenging yourself, and that you've had a go at some of the problem solving over here as well if you've completed everything else and are feeling confident. Some of these can be quite tricky. We've gone through a couple of little examples today, so I hope you can have a little bit of a try to see if you can find some of those missing numbers. Remember, you might not get there first time, okay, but use your excellent maths knowledge to help you to get there as quickly as you possibly can. Now, some of you will be saying, I've done all of this, okay, all of this is sorted already and I'm feeling really confident. If you are feeling like that, I have something extra for you today. So we've got some questions here for you, a little bit like the ones we just did at the beginning of this video with some bars to fill in the equivalent fractions, and then some missing numbers, and a little bit of a problem solve here. I need you to explain to me why Wes is wrong. Wes is saying that 5/6 is equivalent to 7/8 because whatever you do to the top, you also do to the bottom. Now you hear this a lot when you're finding equivalent fractions, and you need to be more precise than Wes is being. You need to look carefully and think, well, what has Wes done to his denominator and to his numerator? Okay, again, much better mathematical language than just saying the top and the bottom. And why is he incorrect? Because I've said you have to multiply the top and the bottom, the numerator and the denominator, by the same factor. I wonder if you noticed what I said there. I won't say any more. Have a careful think about why is Wes incorrect here, and could you make it correct? You might want to draw a little bar model to help you to explain. Now, I then have two challenges for you. Okay, I've got Mark the Master Wizard, okay, working out some equivalent fractions, just like the ones we were just looking at together. And I said, can you give me 4 possible sets of equivalent fractions, okay, for possible different things that A and B could be. Finally, I've got some different images here, some different representations of fractions. And I want you to look at them really carefully and have a think about what fraction they could possibly be representing, because they are all possibly representing at least 2 different fractions. You might even be able to find more than that. So I want you to look at them really closely and have a think. This is like my top challenge today. I've given a little example for this first one, okay, when you scroll down just a little bit further, because I've looked at this and I said, well, here, my whole thing is a quantity, and it's a quantity of 2, 4, 6, 8, 10, 12 circles. And I have got 2 of them circled. So that could say it's a fraction, which is 2/12. But this representation could also show something different. And you notice I counted them in pairs, and you might have noticed you can see them very clearly sat there together in pairs. Well, in that case then, this is one pair, and there are 1, 2, 3, 4, 5, 6 pairs altogether. So that could show 1/6 of the pairs. I've written that just below here as well to help you. So have a careful look at then the other images, and I wonder what fractions you could show that actually represent this as well. Now, I do know that, of course, if 1/6 and 2/12 are equal to one another, then actually 3/18 would be equal as well. But go careful, because although 3/18 is an equivalent fraction to 1/6 or 2/12, it isn't represented in this image. So you do need to look carefully and see what's actually being possibly represented. I look forward to hearing how you get on from your teachers and from seeing your emails. And I hope you get on really, really well with equivalent fractions. Remember, first job, make sure you're confident on what we learnt on Tuesday and Wednesday. And if you already are, that's when you can have a look there at today's work. Always look back at the other White Rose videos to help you as well. And I hope that my video has been helpful for you today. Have a really great day, guys. Bye.